Okay, topic number 7, proportional relationships. Question 1. Jocelyn was shopping at a farmer's market. She observed the prices of cucumbers at several stands. Which sign shows a proportional relationship in the pricing of cucumbers? Okay, we need a rule. Here's a good rule for us. A proportional relationship on a chart. We're dealing with charts here, right? These are all charts. So we need to deal with a chart, not a graph, not an equation right now, but just a chart. A proportional relationship on a chart will have a constant pattern, and the pattern will include 0, 0. So if you need to press pause and make a note, now's a good time to do it. Okay, so does this have a constant pattern? Well, to go from 250 to 450, we add 1.5, right? To go from 4 to 550, we add 1.5. And 550 to 7, we again add 1.5. All right, so we're good here. We add 5 to go from 5 to 10, 5 to go from 10 to 15, and 5 to go from 15 to 20. So it looks like we have a pattern. Is A going to be our right answer? No. And why not? If we subtract 1.5 from 250, we get $1. And if we subtract 5 from 5, we get 0. So if we remember our rule says we have to have a constant pattern check, but the pattern has to include 0, 0, no check. A is not our right answer. Similarly, B, we have plus 2, plus 2, plus 2 on this side, and plus 5, plus 5, plus 5 on this side, but minus 2 gets us 50 cents, and minus 5 gets us 0. Again, we don't have 0, 0. It's not going to be our right answer. A and B are out of it. Okay, what about D? D has times 2 here, times 2 here, times 2 there. That's a constant pattern. And we have times 2 to get from 5 to 10, times 2 to get from 10 to 20. Uh-oh, that doesn't work, right? Because times 2 would not get us from 10 to 15, it would get us from 10 to 20. So that's no good. Okay, what about over here? Plus 2, plus 2, plus 2, that works. Plus 5, plus 5, plus 5, that works. Minus 2 gets us to 0. Yeah, that's good. Minus 5 gets us to 0. Yeah, that's good. Okay, that's our answer. All right, and another thing that should be noted, if you were to draw a XY graph of this and have this be Y and this be your dollars and have this be X and this is your number of cucumbers, what you would have on this graph would be a straight line originating at 0, because it has to go through 0, 0, and you'd have $2 for 5 cucumbers, $4 for 10 cucumbers, and so on. You'd have a straight line originating at the origin, or starting from the origin, a straight line, and that would be the graph of a proportional relationship. And this is a chart of a proportional relationship. That'll be interesting later. It's going to come back up, so I thought I'd show it to you. And C is your answer, because it is a constant pattern, and the pattern, unlike A and B options, start at 0, 0. And we're good. Okay, question 2. Last week, Len spent $18 to bowl 4 games. This week, he spent $27 to bowl 6 games. Len owns his bowling ball and shoes, so he only has to pay for each game that he bowls. If each of these bowling games costs the same amount of money, what is the constant of proportionality between the money spent and the number of games played? Okay, couple rules on this one. First rule, the constant of proportionality, strange term, comes up here and there, is the rise over run on a graph. The constant of proportionality is the rise over run on a graph. But look at here, we don't have any graphs. We just have an equation. So we don't even have an equation, we just have a relationship. We have $18 to 4 games and $27 to 6 games. So what are we to do with that? Another rule that's just good to know is generally money goes on top. So in a equation, it would be money on top, or in a proportion, it would be money on top. Something else like pounds or time or games here, games on the bottom, and that would translate to money on the y-axis and some other term on the x-axis. And here, time on the bottom. So it would be hours on the bottom and some other term on the top, like miles per hour. Miles would generally go on the y-axis and hours would go on the x-axis because it's money on top, time on the bottom. So that's your general rule. So okay, here I put these rules together. You have money on top and you have constant of proportionality is rise over run. Well, then I'm going to conceive of this question as dollars per games, right? And I'm going to find out my rise over run or my constants of proportionality with dollars per games. I'm going to have dollars on the top or dollars on the y-axis, like we talked about. And if I use proportions to tell me how much rise I'm going to get for every run of one, well, that would be $18 per 4 games. Remember, dollars goes on top. We'll cross multiplication and division. 18 times 1 divided by 4. Plug that in your calculator, you're going to get 4.5. So that would be one game is equal to $4.5. And here, let's just see if it's the same. Another cross multiplication opportunity. 27 times 1 divided by 6. Yes, do that in your calculator, and again you will find it equals to 4.5. So for every game, and we're told that all the games cost the same, for every game you're going to pay $4.50. You're going to rise $4.50 for a run of 1. So you're going to rise, if you think of this as rise over run, you can think of this as rise of 4.5 over a run of 1, which equals to just 4.5. So that's your constant. Every iteration of one game is going to cost you another $4.5. So every iteration of another game is going to cost you another $4.5. That's why it's a constant, and that's why 4.5 is the right answer. And we're good. Okay, question 3. The relationship between the length of one side of a square x and the perimeter of the square y can be represented in an xy plane by a straight line. Which of the points with the coordinates x, y lie on the line? And I do have sympathy for you guys. This is complicated stuff when you're dealing with proportional relationships in the world of charts and graphs. Some of the questions can sound not only, weird, like esoteric, like just not what you run into in your everyday life, but they can also just be worded in a confusing way. But let's break it down. We know we have a square, right? Because it tells us one side of a square with length x and the perimeter of y. So if you're just draw out a square and say, if my side length is x, if my side length is 1, let's just substitute 1 in for x, what is going to be my perimeter? So my perimeter is going to be 1, 2, 3, 4, right? And that makes sense, right? If it takes us a side length of 1, it's going to take us a perimeter of 1, 2, 3, 4. So there we go. Side length 1, perimeter 4. And we know x is on the horizontal axis and y is on the vertical axis. So let's just throw that in. Let's just throw in, we know this is going to be side length 1 and perimeter is going to equal 4. Okay, what do we have for 2? If your side length is 2, what is your perimeter? Well, it's 1, 2, 3, 4, 5, 6, 7, 8. Your perimeter is going to be 8. 1, 2, 3, 4, 5, 6, 7, 8. So side length 2, your perimeter is going to be 8. What is this dot? What is that coordinate? That coordinate is in XY notation, right? Because we give coordinates in XY notation. That coordinate is x is 2 and y is 8. X is 2, y is 8. So that's your answer. X is 2, y is 8. Your coordinate of 2, 8 works. And if you continue on, you can say, well, what would 3 be? What would 4 be? What would 5, 6, 7? What would those be? But you don't have to, because you know your answer is going to be B with 2, 8, because you know it's a straight line. It tells it to you. It's a straight line. And you have side 1, 4, 2, 8. That is 2, 8. And we're good to go. But also, just just to point this out. What do we have here? But it is a graph of a straight line that starts at the origin, originates at the origin, which means this is indeed a proportional relationship. So that's where that comes into play. It's a proportional relationship because it's a graph of a straight line that starts at the origin. And here it goes to 0.28, which is your answer. And we're good. Question 4. The graph below shows the relationship between the number of people in a group and the total cost of admission tickets for a circus. So you have the number of people and the cost. Remember, dollars normally go on top, or dollars go on the y-axis for the circus admission. I hope they had a great time. What is the question? The question says, what point on the graph represents the unit rates? All right, so what do we have here? We need a rule. The rule is that the unit rate, and you'll remember the unit rate is normally given as a fraction with 1 in the denominator. The unit rate on a graph is given as 1 comma blank. Sometimes this is known as 1 comma r, but for just to keep it simple, we're going to do 1 comma blank. So if you have a graph of a proportional relationship, it will start at 0. There will be a straight line. At some point, that straight line will pass through value 1 on the x-axis, right? Value 1 on the x-axis, and whatever that equals on the y-axis, that's going to be r, or your unit rate. So when this straight line passes through 1 on the x-axis, whatever it equals on the y-axis, that's going to be your unit rate. That's going to be r, your unit rate. Okay, so some questions are tough even after you know the rule, but some questions are easy once you know the rule. What is the unit rate? Well, it's the unit rate equals x, y coordinate equals the y coordinate when x is 1. When you have x equals 1, here you have 15. So the unit rate here is 115. 1 comma 15. That's your answer. Your answer is B, and we're good. Question 5 is miserable. It is really tough, but we can do it. Let's get started. 3 friends own a landscaping business. The number of hours each friend spends on the same project is shown in the table below. There is that table. So Edgar, 17 and a quarter hours. Good for him. Kelly, 18 and a quarter. Wow, that's a lot. Sean, 14 and a half. Bring up the rear, Sean. Not so good. In total, they earned $850 for the job. They put 15% of this amount into a joint savings account for future expenses. Then they divided the rest proportionally based on the number of hours each worked. How much money did Sean receive? Okay, so they earned $850. So it's a big pot of money. Big pot of money. This is a big pot of money. $850. Then they put 15% into a savings account. That's 15%. And the rest of the money, they divided to Edgar, Kelly, and Sean. But they didn't divide it 1/3, 1/3, 1/3. They divided it up proportionally. How do we even get started? Well, we need to know how much money they divided up proportionally, right? We know $850 started, and we have 15% to the savings account, and the rest is going to go to the proportional division. So let's start with 850. We need to know how much 15% of that is. We do a little cross multiplication, right? Because it's percent over 100 equals what over 850. We do a little cross multiplication, and we get 15 times 850 divided by 100. Plug that in your calculator, and you come up with $127.50. Does that mean they divide up $127.50? No, That means that $127.50 is the amount that goes, is the 15% that goes away, that goes to the joint savings account for future projects. To get this amount, you have to take $850 minus that 15%, $850 minus that $127.50, and what are you going to get? It shows it right here. Just plug in your calculator. $722.50. That's the amount they're going to divide up. If you want to do it a different way, you can say, well, I know this is 100% here. This whole thing is 100%. This is minus 15%. So this here is going to be 85%. And you could find 85 out of 100, cross multiply it to 850, do 85 times 850 divided by 100. And if you do that, you will surprisingly find it is exactly the same, 722.50. Either way you do it, your first step is complete. You have found that this big box of money that they're going to divide up among themselves is $722.50. Okay, so next, how are we going to divide this up proportionally? We can't just divide by 3, right? Because it's proportional to the amount of hours they worked. Well, let's find out how much hours they worked. First, I'm just going to change these into decimals because that's easier to work with in my mind. So I'm going to take 17 and 1/4, do 1 divided by 4. That equals 17 and a quarter, because 1 divided by 4 equals 0.25. Again, 1 divided by 4 here will equal 0.25. So 18 and a quarter gets me to 18.25. And then 1 divided by 2, that's 14 and a half. But 1 divided by 2 is 0.5, so that gets me to 14.5. Take a moment and digest how I did that if you need to. Okay, so now we're going to add up, because we know the total amount of money is $722.50 that they're going to divide. We need the total amount of hours, because the total amount of money is going to be proportional to the total amount of hours. All right, so let's add all these numbers up. 25 plus 25 plus 50, that gets me an even, well, it's 5 plus 5 gets me 10, 0, carry the 1, 1 plus 2 plus 2 plus 5 was 3 plus 4, 5 plus 5 is another 10, carry the 1, 1 plus 7 plus 8 plus 4 is an even 20, so carry the 2, and 2 plus 1 plus 1 plus 1 is an even 5. So there we go. That's a nice round number. That's helpful that the test makers gave us a round number like that. I guess it's not super helpful because we have a calculator for this problem. But we know that $722 is going to be proportional to 50 hours worked. And how much did Sean work? Well, he worked 14 and a half hours. So we're just going to do this. Remember, the question is, how much did Sean receive? So we're just going to do this, a proportional relationship. We have Sean, who received, remember, 14, and 1 divided by 2 is 0.5. Sean worked 14.5 hours. So we do the math. We do 722.5 times 14.5. We divide by 50. Plug that into our calculator. And we find that the answer is A. And we're good. Okay, question 6. Line KN represents a proportional relationship. Point N lies at 1812 as shown on the graph below. And we see that. That's kind of common, right? You know, this is given an X, Y notation. This is 1812. Okay, so that makes sense. Which ordered pair could represent the coordinates of point K? And point K, or line KN, represents a proportional relationship. So we have to remember a rule, and here it is. I've said it a couple times, but now it's a good time to write it down and never forget it if you haven't already. A proportional relationship on a graph, not a chart, but a graph, will hit 0, 0 and be straight. So it will hit 0, 0 and be straight. It will hit 0, 0 and be straight. Okay, so that means the line has to hit 0, 0 and be straight. So let's just draw that line in. Let's draw a line in that hits 0, 0 and is straight. And it goes through point N. Now what are our choices? We need to find a point that's on this line. So 6, 0, 6, 0. That is not even close. It hits 0, 0, not some other number in 0. So, oh, look down here, 1.50. 1.50. I mean, that's close to the line, but we know that's wrong because it has to hit 0.00. It's not going to be some other number in 0. And now we have 2, 2 comma 3 and 7.5 comma 5. So we have 2 comma 3. 3 would be up here, right? 3 would be between 2 and 4. So 2 comma 3, that's not right. And 7.55, 7.55. Well, that actually looks really good. And that's going to be our answer. But, and a lot of people are going to see this decimal, and they're going to be like, oh, that's kind of scary. I don't normally see decimals in coordinate plane notation. Don't be scared of decimals. It's just, they're not scary. They're just what they are. And here, they're absolutely the right answer. And if you wanted to prove it, what you could do is you could say, well, I'm going to find my y to x. I'm going to find my y to x. And I know this y to x, remember this is in xy notation. This is 18, 12. So I'm going to find that as 12 to 18, right? Because that's y to x. And that's going to equal, well, we're going to prove it. That's going to equal 5 to 7.5. And if you do your cross multiplication, 5 times 18, you're going to get 90. And if you do cross multiplication this way, you can do 12 times 7.5. Again, you'll get 90. 90 does equal 90, so you've proven it that that is your right answer. Question 7. Maya uses blue and orange fabric to make identical wall decorations. The graph below shows the relationship between the amounts of blue and orange fabric used. How exciting. Orange is on the bottom, blue is up on the side. And we digest that. We see a bunch of decimals. Again, decimals don't scare us anymore. And we're like, okay, what's the question? What is the constant of proportionality as shown in the graph? And there, we need to remember this rule. We've seen it before, so let's remember it forever if we haven't already. Constant of proportionality equals rise over run on a graph. So the constant of proportionality is your rise over run. And here we go. We're going to go through these and we're going to find our rise over run. Well, 3, 10. So rise 3, or we can, divide these by tenths. Divide these by tenths. Or divide them by 10 to get them into tenths. And 3 tenths will be 0.3 over 1. So if you rise 0.3, we're going to run 1. That's not right. 2 fifths. And, again, let's divide them by 10 to get them into decimals. And 2 fifths, we'll put it up here to keep it simple, will equal 0.2 over 0.5. Rise 0.2, run 0.5. Ooh, that looks so close. That looks pretty close. Should I just circle it or should we go on? Well, I'll probably go on, right? Because if it hits 0.2, 0.5, and it's going to be a straight line, well, it's going to hit 0.4. If you multiply the bottom and the top both by the same number, let's just do 2. It's going to hit 0.4. It's also going to hit 0.5 times 2, or 1.0. So it's going to hit. It's also going to go up 4 and run 1. And if you do that, you can see it's getting further and further away from the line. So this is a really tempting distractor. This question is not only testing whether you know what the constant of proportionality means, it's also testing whether or not you can be precise. And if you are precise, you'll see that that just isn't on the line enough. So that's not your right answer. Let's go to D. D, if we divide by 10 on the top and the bottom, we get 0.1 over 0.2. So we rise 0.1 and we run 0.2. And again, that looks close, but it's not quite right. For example, if we multiply the top and the bottom by 5, would get 0.5 over 1.0. And if we do that, rise 0.5, run 1.0, we'll see again, it's not right on the line. What is on the line? Well, if we divide by 10, we get 0.3 over 0.7. Rise 0.3, run wow. Perfectly hit. And we're good. And now question 8. The lines graphed below show the amounts of water in 2 tanks as they were being filled over time. We have tank A and tank B. For each tank, explain whether or not there is a proportional relationship between the amount of water in gallons and the time in minutes. If there is a proportional relationship, identify the unit rate. Use specific features of the graph to support your answer. Okay, so when you read this question, you can't stop at the first part. You can't just stop at whether or not there is a proportional relationship. There's another part of the question. It says if there is a proportional relationship, identify the unit rates and use specific features of the graph in your answer. Well, you should always use specific features of the graph, but you got to remember to do both parts of the question. Do the complete question to earn all the points possible. And again, you know it by now, but if you've forgotten, a proportional relationship on a graph will hit 0, 0 and be straight. It will hit 0, 0 and be straight. Does this guy hit 0, 0? So no, so it's not a proportional relationship. Does this guy hit 0, 0? Yes. And is it straight? Yes. So it is a proportional relationship. And after that, you know, you just kind of have to work it through. And here's my answer for tank A. Tank A does not constitute a proportional relationship. I know this because the graph line does not include 0.00. Sound good? Tank B does constitute a proportional relationship. I know this because the graph line includes 0.00 and is straight. And the unit rate for tank B is 300 gallons per minute. How did I find that? Well, if I used this dot here, I know this dot is, you know, XY notation, 2 per 600. And I might know my unit rate is 1 comma blank. I know my unit rate is 1 comma blank or comma R. And if I know 600 gallons is to 2 minutes, that is going to be proportional of 300 gallons to 1 minute. You know, divide 600 by 2, you get 300. Divide 2 by 2, and you get 1 minute. And there you go. We're good.